In this session, I'm going to build a naive-based model. So we have a human activity recognition data set. So let's discuss what is human activity recognition. So HAR has emerged as a key research area in the last years and is gaining increasing attention by the pervasive computing research community, especially for the development of context-aware systems. There are many potential applications for HAR, human activity recognition, like elderly monitoring, lifelong systems for monitoring energy expenditure, and for supporting weight loss programs and digital assistance for weightlifting exercise. So I'm going to build a naive-based model. For that, let's import packages. So let's import the basic libraries. So import NumPy as NP, import pandas as PD, import matplotlib, plot as PLT, and import C, import Cborn as SNS. And also we no need for this, we have to import Gaussian naive Bayes. So for that, from sklearn dot naive Bayes, yes, from sklearn dot naive Bayes, we import Gaussian NB, and also from sklearn dot model selection, import plain split, from sklearn dot matrix, we will need confusion matrix. Okay, so we have imported the basic packages. So now let's import dataset. Okay, so let me, so we have two datasets over here, hard validate data and hard data train data. So this hard underscore train data is used for train on build our Gaussian naive-Bayes model. So these are the features that we have, and class is what we are going to do the prediction on. So this is the predictor variable. So these are the predictor variables, and this is the target variable class. So let me import that data set first. So let me call as training as the variable name. So pd dot pd underscore csv of file path we have to mention. So it's r dot train, r underscore train. And also we will pass test data as well. So here test data, if you want to see, so we have to put pd dot underscore csv of. So we have our test data. We will take r dot to underscore validate data. This is our test data. So based on this, we'll do the prediction. So let me run this code. Okay. So now let's see the size. Okay. Training. So let's see the number of rows and columns. Training dot. So we have 13,737 rows and 53 features we have in a training set. And similarly, the test set we have. So in the test set, we have almost same number of features as obvious, and we have 5,885 rows. So let's do the describe function on our data set. So let's do it on test.describe. So before test describe, let's do it on training data. Training.describe. Training.describe. So we got the 5 point summary as well as mean and standard deviation for each of the features that we have. So we have these many features. So here we are actually having that class, right? Class is our predictor, that is our target variable. So it's classification, classified data. I mean, it belongs to class data. So categorical data actually. So we'll deal with that. So the test dot describe. So this is the test dot describe final point summary as well as mean and standard deviation. Now let's see the bottom. Let's see the training dot head. Okay. So training dot head. So this gives the top 5 rows. So this is class we have. So this is all the predictor variables over here are numerical, if you could see. So almost all of them are numerical, except our target variable, which is class E. This is not a numerical variable. This is a categorical variable. If you want to see the unique values that are present, training or dot training of class will pass CLASE dot values, actually dot unique will give us. Okay. Okay, so these are the unique values that we have in our training class target variable. So let's not worry about this for a moment. Let's print head over here. Okay. Now let's print test dot head as well. So test dot head. So let me pass test dot tail instead over here. Let's see the class. So we have class E over here. So now what you have to do is that, so let's take the training. So training of class E, training of class E dot, we have these many unique values. Okay. Now let's create X and Y. Okay. So we have our X train. X train is equal to training. So X train, we want all the columns or all the features except class E, right? So what we'll do is that training dot ILOC of, we want all the rows and we want from first till end. First till end. So let me check exchange. Okay. See, we have got all the values, but we only want values, right? Dot values. So it's centric. Okay. So we have got the values in the form of array. So we have our extend values. Now what we want white train. So white train is train the training of uh, class E dot values. White train. So yeah, we have got extend and white train. So similarly, we want testing data as well for extend we have and white train. So now we will do the same for testing data. X test is equal to test dot ILOC of all the rows and first column till the end dot values. and y test is test dot test of class E. So we have to pass it in inside the quotation mark quotation dot values. Okay. So now let me run this code. Okay. So we have our training data and testing data. So now I'm going to instantiate Gaussian naive Bayes to our model variable. So model is equal to Gaussian naive Bayes. So instantiate the Gaussian naive Bayes classifier. Now let's train the model. So model dot fit of x train comma y train. So let's train our model. So we have trained our model. Now let's do the prediction. So let me pass predictor variable and do model dot predict of x test. And let's print prediction of all the rows and only so till 150 rows are prediction of 150 values. So I have actually extracted the first 150 values since we have so many values like 5,885. So I'm just extracting only first 150 predictions. Now let's do the confusion matrix. Okay, let's build a confusion matrix. So, so inside a heat map, we can build a confusion matrix. But what you can do is that let me do sns dot heat map, sns dot heat map of confusion matrix, confusion underscore matrix of, so I want to pass prediction. So I want to pass diode y test, right? So y test, comma prediction. And after that, we want a not is equal to true. Let me draw this. Okay, we are getting so many values. Dot fmt is format is I'm going to take 0.2%, 0.2 floating point percent. Let me check it if it works. Format is 0.2. If I will give, let me check if it works. Okay, till 241 point I have taken. So, but we just want integers, right? Let me take it as d. D is an integer. So we have got integer values over here. And so this is labeled as 0, 1, 2, 3, 4, right? So let's label these things by xdiv labels. So what we can do is that we can pass use for here is equal to so numpy dot. So whatever unique values are there over here, you can take that. So np dot unique of it. So then you can pass xtick labels. So let's see the parameters that are present. So xtick labels is auto it is considering. So xtick labels and y-tick labels we want. Copy v. So xtick labels will pass it as names and y-tick labels as also will pass names. So we have got A, B, C, D, E, and the different classes that is our predictors, that is our target variable we have. So these, if you put these values in the diagonal, These are true positive, true negative, or true class A to class B to class C to class D to class E values. Okay. So these are true classes values, and we can get rid of this bar. We have to put C bar is equal to false for that. Let me print. Okay. So we don't have that C bar. So let me pass plt dot x label as x label as so x label is our y test, right? So y test is our actual value. Y test is actual or predicted. Uh, so past y test comma y test comma predicted, right? Uh, so let me pass it as y test comma y predicted over here. This order prediction comma y test. So works level of actual or true comma plt dot y label as predicted. Okay, so these are the true values, x-axis, and y-axis is the predicted values. Since we have passed in confusion matrix predicted comma y test, so have got our confusion matrix with true and predicted values. Okay, the thing is this holds right. Okay, this should be actual, or this should be actual, this should be predicted. Okay. Okay, what you can do is that you do y test comma predicted over here and you change y label to true and x label as predicted. This is fine. So this is the true values, these are the predicted values. So y test comma prediction. This is how we form this confusion matrix on a heat map. Now what you can do is that you can build a classification report. So we have already imported a matrix, I guess. So we haven't. So from sklearn, import matrix. Okay. So now matrix dot classification report of. So we have prediction, comma y test, comma we have to pass labels. So labels is equal to np dot make of prediction. So we have got this kind of a classification report. So we have to pass inside print to get it in a proper format. So this will give a print proper format. So this is the classification report. So the precision is 64% of the time a class belongs to A. So like I mean, this is a classification report. This is not accuracy. Okay. So we have all completed the naive-based model. So this is the end of this session. Thank you for attending the session. Hope I will be covering the support vector machine and K nearest K means clustering in the next coming classes. Thank you.